Hello everyone, I am Afra Mulla from Sri Siddheshwar Women's College of Engineering, and in this video we are going to solve one simple problem from engineering mechanics. So let's see what our question is. Our question has given us an equation, that is S is equals to 2t cube minus 6t square minus 8, where S is our displacement in meters and t is time given in seconds. Now using this equation we have to find, or you can say calculate, displacement and acceleration when velocity is 0. Now we are only given with displacement. How can we find velocity and acceleration through it? Then we have a simple way. When displacement is differentiated with respect to t, we get velocity, and when velocity is differentiated with respect to t, we get acceleration. So before actually going to question, let's find the equation for velocity and acceleration. So for velocity, that is we can find it by simply differentiating our displacement, that is ds upon dt. That would be nothing but 2t cube will be differentiated as like 6t square minus 12t. Now this is our equation for velocity, and for acceleration, that is a differentiating v with respect to time, that is 12t minus 12. Equation 2 for acceleration. Now we have found velocity and acceleration, not the values but the equations which will give us velocity and acceleration by using this equation. Now our question says that calculate displacement and acceleration when velocity is 0. To find when velocity is 0, we can see here first of all that our term velocity, variable v, it is depending on only one variable, that is time. So at what value of time will our velocity become 0? To find that, we will simply put our velocity equals to 0 in this equation. So in equation 1, put velocity is equals to 0, because our question is about displacement and acceleration when velocity is 0. And when will velocity become 0? Our velocity is dependent upon time. So using time, we make our velocity 0, and on that time we will find displacement and acceleration. Let's see. In equation 1, put v equals to 0. So what is our equation? That v is equals to 6t square minus 12. Now value of v is nothing but 0, is equals to 6t square minus 12t. Now if we simplify this, first of all I will take 6t common from it. 6t common, t minus 2. Now here, as we know, it will be simply either 60 for this whole term to be 0. Either this should be 0 or this should be 0. That is, either 60 should be equal to 0 or t minus 2 should be equal to 0. That is, t is equals to 0 and t is equals to 2. So we found that at values of, when we put t is equal to 0, then our velocity becomes 0. When we put t is equals to 2 in this equation, our velocity will become 0. So these are the time at which velocity will become 0. And when velocity is 0, we have to find displacement and acceleration. So we have to simply put time t is equals to 0 second in the equation of displacement and acceleration, and t is equals to 2 once again in displacement and acceleration. So for that, first we will do for t is equals to 0 second. For t is equals to 0 second, our displacement S is equals to 2. Let's first write the equation. So that will be 2 into 0 cube minus 3 into 0 ka square minus 8. That is nothing but minus 8 meters. Now here minus indicates the direction. So S is equals to 8 meter. Then acceleration. A is equals to 12t minus 12. So we are finding acceleration when t is 0. When t will be 0, our velocity will eventually become 0. So here what we are finding is the value of displacement and acceleration when our velocity is 0. So 12 into 0 minus 12. That is minus 12 meter per second square. Now we have one more value for t. I'll solve it here itself. For t is equals to 2 seconds. S will be equals to 2 into 2 cube minus 6 into 2 square minus 8. That is nothing but 2 into 8 minus 6 into 4 minus 8. That is 16 minus 24 minus 8. That would be nothing but minus 16 meter. Here negative sign indicates direction. Now acceleration when t equals to 0 will be 12 into 2 minus 12. That is 24 minus 12. That is 12 meter per second square. So we have found the values of displacement and acceleration when velocity is 0. This is the required answer for our question. I hope you understood what we did in this video. Thank you for listening till the end. Bye bye.